So you have to look what certain parts have. So as far as a median, okay, vertex and a midpoint. Vertex and a midpoint. And when you're trying to pick these out of diagrams with multiple lines on it, you're looking, okay, median I know is vertex and midpoint. Now what does that mean? That means that the line is going from an angle of the triangle to the midpoint of the other side, which means that your side is going to have single slash, two equal pieces, which means that if this is 5, this is 5, and the whole thing here, 10. Okay, the whole thing here would be 10. And that's the thing you want to understand. Here's your midpoint. And just, yeah, now you can have in one triangle more than one median. All I have to do is connect a vertex and a midpoint, and then I could say, okay, this is 8, and then this is 8, therefore this whole thing is 16 here. Okay, and I could draw another one. And if you see, you get this idea that there's a central part here. Okay, that's your median. Now, as we spoke about, altitude, when dealing with, let's say, a plane taking off, it reaches a certain altitude, or a pilot will fly a plane to a certain higher altitude because the conditions are more conducive to flying. Let's say there's less wind, they're not going through any sort of like weather system. So they say they reach an altitude, and then that altitude is measured by drawing a line straight down to wherever zero elevation is, wherever the ground is, basically ground floor, ground level elevation. Now, how do you determine whether or not this is straight down? Well, in order to draw a straight line down from a certain point, the quickest way to 2 points, or to determine that, is a right angle. That right angle is telling you that this point is going straight from here to here. There isn't any deviation as far as angle. This is a perfect, with ground floor, a perfect right angle, and that's how you determine an altitude. So an altitude needs a vertex, and I just say like it needs a perp. I use that a lot. It needs a perpendicular. Okay, and that's how you determine an altitude. Now you can have certain triangles like this here, in which the altitude is actually one of the sides of the triangle. You could also, because that is because this line is directly perpendicular to a base, and this side of the triangle is that line, this here could be your altitude. Now another thing to consider is, well, let's say I have a triangle that is slanted like such, right? And I'm trying to find what is the height of this point here. I don't particularly like this marker. One way to do that is you can actually draw a line exterior to the triangle and extend this base. Extend this base and make a perpendicular line here. Let's make some slashes to show that it's not part of the triangle. I'll actually change the color of this triangle so we see it differently. Here I've actually drawn an altitude. I've drawn an altitude outside the triangle, and this is the best way to measure like a perfect height, as far as what is the distance from this point and to a base, and that's your altitude. Now, one thing to consider with altitudes, and which we've done before in the past, if you look at a triangle, it has a base and it has a height. Now your height looks like what? Your height looks like an altitude. And what's something that we dealt with in a triangle with a base and height? We dealt with area. And area was your base times height over 2. We actually did a full presentation on that. All right, so here you have, now what if they asked, what is the altitude given a base of 10, or they may say like AC is 10, what is the altitude or the height if the base is 10 and the area is 25? Well, that becomes an algebra problem. You know that, what'd you say? You know the area is 25. You know your base is 10. 10 times what number? In this case, your height, or let's say you're looking for your altitude, divided by 2 gives me 25. Well, I can multiply both sides by 2. 50 is equal to 10a divided by 10. And my altitude here will be 5, which makes sense. 5 times 10 is 50. Divided by 2 is 25. So they may ask you to solve for an altitude. They would have to give you a base. They would have to give you an area. Another simple kind of diagram or thing to look at is this perpendicular bisector, PB. Not PB and J. It's not peanut butter. It's a perpendicular bisector. It is what it says it is. You don't need a vertex. The vertex is not something that is necessary to draw a perpendicular bisector. What's necessary is the fact that you find a midpoint on a line in order to bisect that line. And you need to draw a line which perpendicularly bisects a side of a triangle. And that's all this does here. And again, if this is 5, this is 5. If it's bisecting something, it's cutting into equal pieces. That's all you need to know about a perpendicular bisector. Now, you can have, what if I had is this a perpendicular bisector? Absolutely it is. Yeah, that's a PB. It's perpendicular. It has a right angle. And it's also bisecting. But also it has a vertex. So actually in this case, our PB is also an altitude. So here you have a case, and you may see in more cases, other cases as well, that you have one like diagram or one piece of a triangle here which represents two things, a perpendicular bisector and an altitude. Represents two things that can happen. This we've seen before in an angle, but a triangle is made up of angles. So you can have what we call an angle bisector. And you need an angle, and it needs to be bisecting. What you'll see, we talked about notation when we did triangle congruence. That in order for me to say these two triangles are congruent, are angles, I don't need to give a measure. I could just give an arc. And these two single arcs are telling me that these two angles are congruent. You may even see an arc with a single slash to show you, hey, these two angles are congruent. Now if I drew another line here, another angle bisector of this triangle, I would have to say these are congruent by making 2 slashes here, and then the same thing up here with 3. And now the idea is if you had a triangle, all right, let's say I had a triangle with 2 angle bisectors. And let's say this was 70 and this angle here was 50. And I wanted to know one of these 2 angles. Well, you say, okay, 180 minus 120 gives me 60. I know this whole angle here is 60, and if it's bisected, both of these are 30 and 30. Nothing fancy there, just bisecting an angle. And the last thing, which does have a couple pieces to it, which we'll be working with probably more so than any of the other parts, is this thing called a midsegment. This is big in a triangle. And what you see here is you see 2 midpoints, single slash, double, double. So I'm telling you that both these sides are equal. They're both 5 and 5. They're both 10 and 10. I'm telling you that I'm connecting one midpoint to another. Now the thing to know about a midsegment is that the midsegment and its base are a 2-to-1 ratio, meaning that if this is 8, this here will be 16. Now if I give you a triangle with a midsegment, and I say this is 8, let's call this 10, and let's say this is 18. And I ask to fill out the rest of this triangle, the rest of these pieces. Let's say this piece, here, and here. Well, you're saying, okay, I know this is a midpoint. I know I have two equal pieces, so I would say this is 8. I could also say that this is 16. Since this is 10 and this is a midpoint, I can say both these pieces are 5. And since I know this is a 2-to-1 ratio, if this is 18, this will be half of it, this will be 9. That's the part you really got to focus in on, is that fact that this is basically, they'll give you an algebraic model which will have an x and a 2x. So basically whatever this is double, and whatever this is half.